Today I'm going to talk about taking a small argument limit of a quantity or an expression that we saw in chapter 2, question number 6. And I'm going to use, I left this series expansion of a natural logarithm of 1 plus x for you, and we will use that particular expression to do that. So let me remind you what it was. So it's taking c over r much bigger than 1 limit of this expression in question number 6. And if you don't remember, let me remind you what that was. It was asking us for non-uniform charge density, which was equal to rho dV. So the smart way of doing that was realizing that at this particular limit, rho goes out of the integral, and that expression at this limit, rho became a over c. And then realizing that this became a over c times dv, and remember that this dv for a sphere was 4 over 3 pi r cubed. So this is how we did it. Now what I'm going to do is I'm going to show you that this mathematical expression, taking this limit, if you were in an exam and if you couldn't see this, that this becomes uniform and you can take it out. But if you have this expression already, and how am I going to take that limit? And I'm going to try to give you the answer to that. And the problematic thing about this limit, as you can see, when c over r is much bigger than 1, this expression is big. It's very big. But the other expression here, logarithm of 1, is 0. So it's a big number multiplied by 0. How are we going to do that, right? So we are going to use this, the series expansion of 1, logarithm of 1 plus x in here. Okay, so you see that this whole thing will become, so if I take this, so let me write it here, logarithm of 1 r over c. So taking the limit of r over c is being small, right? Because when c over r is big, r over c is a very small number, right? So if I define r over c as x, this is the logarithm of 1 plus x, and that's equal to x minus x squared over 2, and it goes like that, right? So that's x minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4. So it goes like that. So now I can write this whole expression as, so let me put it right here. That's the constant term, 4 pi a times r squared. So that would be 1 over 2 minus c over r plus c squared over r squared. So the first term in this expression is x, which is, remember that x is equal to r over c. So that's r over c. The second term is r over c squared. The third term is r over c cubed. And there are higher terms, higher order terms. So you see that this times that gives you r's cancel and you get c over r. This times that gives you minus, and you have r over c squared with a 2 in here and a 3 in here, right? 2, 3, and 4. And this gives you r over c, r squared over c squared exactly cancel that, and you only have minus 1 over 2. And the final term gives you r squared over c squared cancels, and you're left with r over c with 3 on the denominator. So if you make this expansion, what you would see is the c over r with a positive, so let me use this, c over r actually get cancelled by minus c over r here, and minus 1 over 2 gets cancelled by 1 over 2. So you are left with this term multiplied by that term. So q total becomes 4 pi a times r squared times this term, which is r over 3c. And as you can see, this is exactly the same as this term, because this is nothing but, again, let me write it, 4 pi r cubed, the 4 over 3 pi r cubed times a over c. So if you just follow math and use the expansion, the series expansion of a logarithm of 1 plus x, you can actually show that mathematically at this limit, low argument limit of this logarithm expression, you can actually show that you get exactly the same thing as actually seeing that it becomes a constant and taking it out and basically multiplying by the volume of the sphere. So you see that both of these expressions, so you see this is A over C times that, this is exactly the same as that, right?